In this video, we will be finding the area between two curves. And for our first example, we have f of x equals x squared and f of x equals x. So let's give a quick sketch of what we're working with. So our first function is f of x equals x squared. So it is a parabola. So it looks something like this. And our other function is f of x equals x, which is just a diagonal line, which looks something like this. So let's just label this f of x equals x squared and f of x equals x. And now we have to find the area in between the two curves, so the shaded part. And we would do this by using a formula, which is the integral from the lower bound to upper bound. And in the integrand, we would have to plug in the upper function minus the lower function. And all of this will make sense with an example. So with our example here, we have f of x equals x squared and f of x equals x. So we first have to find where these functions intersect. So what we could do is we could set all these functions together. So x squared, which is equal to x, and we could solve for this equation now. So we could just move everything onto one side and factor it out. And that gives us x, which is equal to 0 and 1. So you can see here, we have 0, x equals 0, and x equals 1. And now we could plug everything into our integral. So let me just erase what we have here. So following our formula, we have the integral from 0 to 1. Our upper function, you can see, is x, and our lower function is the parabola. So you can see the upper function is here, and the lower function is the parabola. So we have x minus x squared. So this integral is pretty straightforward. So we just have to apply the power rule. So we have x to the power of 2 over 2 minus x to the power of 3 over 3. And our bounds from 0 to 1. And now let's substitute our upper bound. So we have 1 to the power of 2 over 2 minus 1 to the power of 3 over 3. This is our upper bound. And now minus our lower bound. So we have 0 to the power of 2 over 2 minus 0 to the power of 3 over 3. And all of this will go to 0. And now we just have to compute for this part. So we have 1 over 2 minus 1 over 3. And that gives us 3 over 6 minus 2 over 6. And our final answer will be 1 over 6. And 1 over 6 will be our final answer. In our next example, we have f of x, which is equal to e to the x, and f of x, which is equal to x plus 1, from the bound 0 to 1. So let's sketch this out quickly. So the function e to the x will look something like this. So f of x, which is equal to e to the x, and f of x equals x plus 1 will look something like this. And once again, this isn't the nicest drawing, but this is just to give an idea of what the functions we're working with look like. So we have to find the area from 0 to 1, because this is what the question is asking, from 0 to 1. So we have to find the area in between these two curves, which is the shaded part. And to do that, we use the same formula. So we have the integral from 0 to 1. Our upper function is e to the x minus our lower function, which is x plus 1. And let's solve for this integral now. So we have the integral of e to the x, and the antiderivative of that is e to the x, minus the antiderivative of x is x squared over 2, minus the antiderivative of 1, which is simply equal to x. And now we can just substitute the bounds. So first, let's substitute the upper bound. So we have e to the 1 minus 1 squared over 2 minus 1 minus our lower bound now. So our lower bound, we have e to the 0 minus 0 squared over 2 minus 0. And now we can just simplify everything. So we have e minus 1/2 minus 1 minus, and then e to the 0 is 1. So our final answer is equal to e minus 5 over 2. And here would be our final answer for this question. In our next example, we have x equals y squared and x equals y plus 2. So let's give a quick sketch of these two curves. So x equals y squared will look like a parabola that's sideways, and x equals y plus 2 is just a diagonal line, like this. And let's label everything. So we have x equals y plus 2 and x equals y squared. And we have to find the area in between these two curves. So let's find the upper function, which is this part of the sideways parabola. And our lower function will be the first part of the sideways parabola. And then the second part of the lower function will be the diagonal line. And although you can work with these two functions that are split apart for the lower functions, it is more work. So another way you could solve this problem is by using this formula that I'm about to show you guys. And we will be integrating this in respect to y. So we have the integral from the lower bound to upper bound, and the integrand, you will have the function on the right minus the function on the left in respect to dy. So you can see in this example, our function on the right is simply x equal to y plus 2, and our function on the left is x equals y squared. And here we could just do this in one integral. So now let's find our intersection points. So we want to find these 2 points where the two functions intersect. And what we do is we set both of these functions equal to each other. So y squared equal to y plus 2. And we can move everything onto one side. So we have y squared minus y minus 2. And now we can just factor everything. So we have y plus 1 times y minus 2. So y would be equal to minus 1 and 2. So for this function, in respect to y, we have minus 1 here and 2 here. So let's plug everything else into the integral. So we have the integral of minus 1 to 2, and our right function would be y plus 2 minus our left function, and our left function will be y squared. and we integrate this in respect to dy. And now let's compute this integral. So we have the antiderivative of y, which is y squared over 2, plus the antiderivative of 2, which is 2y, minus the antiderivative of y squared, which is y cubed over 3. And let's define our lower bound and upper bound. And to compute this, I'll leave this for an exercise for you to do. But the final answer for this would simply be 9 over 2. And here is our final answer. If you found this video helpful, please leave a like and subscribe to the channel. And please comment down what other video topics you guys would like to see. Thank you for watching.